Okay, today we're going to talk a little bit about making equations based on a given graph. So we have two choices when we're looking at a graph. We can start with an equation in factored form. So y equals a, our stretch factor, onto x minus p onto x subtract q, where p and q are our x-intercepts. So this is the best equation to start with if we're given our x-intercepts. We could also start with vertex form. Y equals a, our stretch factor, onto x minus h squared plus k, where h and k are the x and y coordinates of our vertex respectively. So depending on what information we're given on the graph decides what equation or quadratic equation form we should start with. So here we're given two x-intercepts. We have an x-intercept at 1 and we have another x-intercept at -1. We're also given the vertex. So because we have both of those pieces of information, it doesn't matter which form we choose to work with, either factored form or vertex form. I'm going to choose factored form because I think it's easier. So when we use factored form, we've got y equals a, and we don't know our stretch factor yet. That's something that we have to calculate later. But we do know our x-intercepts. We've got 1 at -1, so we change the sign on that to be x plus 1. And then we've got 1 at +5, so we're going to change the sign on that to give us x subtract 5. So there's the basis of our work so far. We've got factored form, and we've inserted our x-intercepts into that form, making sure to change the sign. Now the last step, or the next step, is to solve for a, our stretch factor. We already know that a is going to be a positive number because our graph is opening upwards like a smiley face. When a is positive, we have a graph that's opening upwards. But we do need to find out the exact value of that number. So in order to do that, we're going to use the only piece of information we haven't used yet, which is our vertex, 2 and -9. And what we're able to do with this is plug in 2 for all of the x's, and plug in -9 for the y. And what that's going to do is break our equation down to have just one unknown, this a value, that we're then able to solve for easily. So y becomes -9, and x becomes 2. So we've got 2 plus 1 onto 2, subtract 5. We can then simplify those brackets a little bit. -9 equals a multiplied by 2 plus 1, which is 3, multiplied by 3 subtract 5, which is -3. So we've got -9 is equal to 3 multiplied by -3, which is -9a, which gives us an a value of 1. Now we can plug that back into our factored form to give us y equals 1. We don't have to write that if we don't want to. Onto x plus 1 onto x subtract 5. This answer is perfectly fine the way that it is because the question doesn't specify the form in which we should leave our answer. Sometimes it might ask us to leave it in standard form, in which case we'd have to expand out these brackets using binomial expansion or FOIL or lobster claw, whatever you want to call it, and leave our answer in the form ax squared plus bx plus c. But because it doesn't specify what form we need to leave our answer in, we're fine leaving it in factored form. So the last example that we'll talk about today is when we're given the vertex and a y-intercept, or the vertex and another point anywhere on the graph. So here we can see that the vertex is at 1, -6. So we're given our vertex. We can also see that our y-intercept is here at 0, -5. We can see our x-intercepts in this example, but it's hard to tell exactly where those x-intercepts lie. So we're not going to use those. We don't want to make an approximation there. So if we have our vertex and we don't have our x-intercepts, we want to use our vertex form in order to start this question. So we've got y equals a onto x minus h squared plus k. So we can plug in our coordinates for our vertex into h and k. So we've got y equals a onto x minus 1 squared, subtract 6. Here, it follows the exact same pattern. We need to find the value of our stretch factor. And how we're going to do that is to use our extra point. So we've got this point, negative 5, 0. We're going to plug the negative 5 in for y and the 0 in for x. Negative 5 is equal to a onto 0 minus 1 squared. Subtract 6, and we start to simplify. We've got negative 5 onto a times negative 1 squared, subtract 6. And I would start by taking this 6 over to the other side here. So we're going to get rid of that 6. Negative 5 plus 6 is 1. These two are going to cancel out. And we're left with a multiplied by negative 1 squared, which is just 1. So again, our a value here works out to be 1. And that gives us a final answer of y equals 1, which we don't have to write if we don't want to, onto x minus 1 squared, subtract 6. And it's perfectly fine to leave this in vertex form because the question doesn't specify what form we need to put it in.